In last video, we talked about how atoms can interact with each other in order to form a molecules, right? So in this particular situation, we have a carbon to make a biomolecules. So carbon is a very tricky atom because carbon can neither give electron or take electrons. So carbon can only share electrons with other elements through the formation of covalent bond. So here I have a methane that shows one carbon with 4 hydrogens. So all these shared electrons is one covalent bond. So we can draw a simple diagram to demonstrate the formation of methane. We have one carbon with 1, 2, 3, 4 covalent bonds with 4 hydrogen elements. So this is what we call a simple biomolecule, which is a methane. It has a central atom, which is right at the center. So as you can see, carbon can always make 4 bonds, and it doesn't have to be with hydrogen. It can bond with other carbon as well, right? So here I have one carbon can make 4 bonds, so this carbon can form another bond with carbon, with another carbon, with another carbon, with another carbon. So now I have this long chain hydrocarbon. I call this a hydrocarbon because for the other 3 bonds that the carbon is not bonding with another carbon, it is bonding with hydrogen. So remember, each carbon can have a maximum of 4 bonds. So here it looks like a very long methane. We don't call this methane, it has a different name, which is not the focus of today's class. But the idea is that carbon can make long chains with other carbons and with other elements. When you have a long chain situation like this, we call this a straight or linear hydrocarbon chain. Hydrocarbon chain. The idea is that each carbon is connected next to other carbons in a long chain and a straight line. And it doesn't even have to be in a straight line, it can branch out to other directions as long as carbon has 4 bonds that's attached to carbon. So I have this carbon, it needs to have 3 other bonds so that it has a total of 4 bonds attached to this central carbon. And this carbon already has 2 bonds to it, so it can have another 2 more bonds for this carbon. So if you stick to the rule, each carbon will always have 4 bonds. So let's just make another carbon chain that branch out from this original long chain hydrocarbon. So remember, hydrocarbon just means a long chain carbon that has only carbon and hydrogen. So now what I just created is a branching hydrocarbon chain, because if we look at all the carbons, it has a backbone that looks like this. So this particular section is the branch section. And we call this type of formation a branch chain. So where is the branch chain? It is really this part. It doesn't even have to be a single bond, right? We know that carbon can make single bond like the previous examples that we have, but it doesn't even have to be a single bond. Carbon can form double bond with another carbon. And as usual, each carbon can only have 4 covalent bonds attached to the central carbon. So let's look at this central carbon. Let's just focus on this particular carbon. This carbon already has 2 bonds attached to it, right? 2 bonds attached to it. So the remaining 2 bonds will be branching out here. And this carbon also has 2 bonds, which is here. So it has only remaining 2 bonds left. It doesn't have to be 2 carbons. It can even make carbons with different bonds, different configurations, as long as that particular central carbon has 4 bonds. So if you do the calculation and observe clearly, each carbon in this picture always has 4 bonds. So carbon can make a double bond or even triple bond. So remember, each stake represents one covalent bond. It doesn't even have to be hydrogen. It can be oxygen as well. And we have to look into the configurations of the electrons at the valence shell for oxygen. So oxygen will need 2 extra electrons in order to fulfill its octet rule. So usually oxygen will have 2 covalent bonds. So in this situation, so this oxygen and hydrogen is a group of atoms in molecule that interacts in a predictable way. We call this particular groups a functional group. Functional group. So we have many different kinds of functional groups that usually have a very special name and they have very similar properties. Our class, you need to at least remember 4 types of functional groups. The first functional group is a hydroxyl group, OH. So it is made with 1 oxygen attached to a hydrogen, hydroxyl group. The second functional group that you need to know is a carbonyl group. Carbonyl group is made of a carbon with an oxygen that is double bonded to the carbon. So this is a carbonyl group. Third group that you need to know is carboxyl group. It is made of 1 carbon with a double bond oxygens and a single bonded oxygen with a hydrogen, which is a hydroxyl group. That central carbon will need to have a 4th covalent bond. The last group that you need to know in our class is an amino group, which is made of 1 nitrogen and 2 hydrogen. So this is an amino group and this is a carboxyl group. They give different properties or behavior to the molecules that they're attaching to. So think of them as like some sort of Lego pieces that you can just add on to the biomolecules that you wanted to create. And if you attach this functional group differently, depends on how you put it in, you'll give this hydrocarbon chain different properties, which means they will have different behavior and they will come up as different molecules. So remember that you have 4 functional groups that you need to remember: a hydroxyl group, a carbonyl group, a carboxyl group, and an amino group. We will cover more in details of what different kind of biomolecules that they can create by just attaching these functional groups like Lego pieces to the hydrocarbon chain.